Well, I'm sorry that I cannot be with you in class today, but I wanted to take a few minutes to talk about scale drawings. I'm particularly looking at a blueprint like you see on the screen right now. So what you have in front of you, imagine this is my classroom here at Wesleyan. You've got the length and width of the classroom. You've got 4 inches and you've got 3.5 inches. You've got 1/3 of an inch for the doorway. Leading into the classroom, you got 1/3 of an inch to the doorway leading into the closet. And then you see the closet is 4/5 of an inch by 4/5 of an inch. So this is all the model, okay? And then you see the scale right here. So if I said, what is the scale of the drawing? Well, you simply take 3 inches, which represents an actual length of 12 feet, and you say, well, what does that represent for 1 inch? Because the scale, we always want to have a unit of 1. Well, you'd simply say that divide each of those by 3, and 1 inch would equal 4 feet. So again, what that means is for every 1 inch on this map, the actual width or length or size of the classroom is 4 feet. So every 1 inch on the map is 4 feet. So the question here says, what are the actual dimensions of the classroom? Now, actual means what are they in real life, and dimensions means the length and the width. So we're going to have 2 calculations. Well, remember what I said yesterday. We always say we put the model over the actual equals the model over the actual. In this case, the model is the actual blueprint that we're looking at. So it says, what are the actual dimensions of the classroom? So what we're looking at is the classroom as a whole. We're looking at the length, the width, and the length. Okay. To give you an idea of what your answer is going to look like, some of you have probably heard somebody say, "Hey, the drawing is, or the picture frame is 5 by 7. Those are the dimensions. 5 inches by 7 inches is the size of the picture frame. Or the dimensions of the room are 15 feet by 25 feet. Again, that means dimensions. There's the length and the width, or you can reverse that, width and length. So we're going to have 2 calculations. So we know that if our scale is 1 inch to 4, we're going to start with 1 inch to 4 feet, and that's going to equal inches over feet. Okay? Well, let's take the width of the classroom is 3.5 inches. And by the way, I apologize that I don't have a perfect square here. Hopefully, if I was actually doing this, I would use a ruler and make this nice and pretty. But here we go. So the scale is 1 inch to 4 feet. And let's take a look at the width right here. 3.5 inches on the drawing. So I'm going to put 3.5 inches, and I want to find the actual length. So here's my calculation. I'm going to say 1x equals, and then it's going to be 4 times 3.5. So I simply say 4 times 3.5. That gives me 14. So x equals 14 feet. Okay. So this is going to be 14 feet in real life. And then we want to find this calculation, which is 4 inches. So I literally do pretty much the same proportion. 1 inch over 4 feet equals 4 inches over x feet. The 4 inches I get from up here. Boom. X equals 16. Or 1x equals 16. So x equals 16 feet. So you would say the dimensions are 14 feet by 16 feet. So that's actually how big the classroom is, quote, in real life. The third question says, what is the actual width of the door leading into the classroom? Well, you've got a door here and you've got a door here. This is saying the door leading into the classroom is 1/3 of an inch on the scale. So come down here, the model is 1 inch, is 4 feet. Okay, so 1/3 of an inch over x feet. You may be saying, well, Mr. A, how am I going to do 1/3? And what I would tell you to do is this. In the calculator, do 1 divided by 3 first. Leave that number in your calculator and then multiply it by 4. Multiply that by 4 and you get 1 1.3 repeating. Again, I did 1 divided by 3, which that's 0.3 repeating. And then I say times 4, that equals 1.3 repeating. I'm going to say 1.3 feet, and I'd have to tell you round to the nearest tenth of a foot. So, again, on the drawing, it's 1/3 of an inch. In actuality, this is going to be 1.3 feet. Now, I'm sure some of you are saying, well, Mr. A, can't I just multiply it by 4? Can't I just say 3.5 times 4 and 4 times 4 and that's a 4? You're exactly correct. The only thing I would caution you against is you need to know what to do if you're going to find something different. Okay? So let's say I told you what the actual feet were, and you had to come up with a model. You would have said 1 inch over 4 feet equals, let's say I told you, I'm just making this up. Let's say on the model I said, let's act like I have a desk right here, okay? And let's say in the model, the desk is, I don't know, 2/5, or not, sorry. Let's say in real life, the desk is 3 feet long, okay? 3 feet long. And then my question would be, well, how big is it on the model? So here I would say, I don't know how many inches it is on the model, but I know that it's 3 feet in actuality. So what's it going to be? So I would have 4x equals 3 divided by 4. And we know that 3 divided by 4 is 0.75 inches. So that would be what it would look like on the desk on the actual drawing. Anyhow, there's your quick lesson on scale drawings. Hope this was helpful to you. Have a great day.